Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up 55 is on the screen. Shouldn't take you long for that. As soon as you're done with that, make sure you grab 3 graph papers. We're moving on today to another section. Get started, please. All right, let's get the show on the road because we have some stuff that we need to cover. All right, number 1, I need a compound inequality, and I'm going to start it off with solution set of x such that, and close it over here, but I need my inequality. What is my inequality? Oh, we said Mario was done. Yes, Mario, inequality, go. 0 less than x. 7, let's see, 1, 2, 3, 4, 5, 6, 7. Hands, have you got that? Looks about right. I need a solution only for number 2, x1 and x2. 2 of them, 2 solutions. All right, so since you already checked with your neighbor and you already turned it in, let's go back to Caesar. X and x. 2, yeah. I don't need the process, I just need the solutions. Negative 10, negative 2, okay, hold on, negative 2, and negative 3. Hands, have you got that? That is correct. Yes. Number 3, I need an equation for number 3. F of x equals what? Pass it to someone. Caesar. Rogelio, f of x equals? F of x equals? All right, help him out, Sebastian. F of x equals 1 over 5x plus 2. Hands, have you got that? That is correct. Our y-intercept is right here. If we place another point, I'll place it over here. It's going downward, down 1 step, and 5 to the right. So this is negative 1 over 5. And number 4, I need the inverse, and it looks like Enrique's got this. So before Enrique gives me the inverse, tell your neighbor what you got for your inverse, please, to make sure we got that. Inverse. All right, Enrique. X minus 20 over negative 4 equals f of x with a little negative 1 on top. Hands, if you got that? That is correct. Make sure you turn that in, please. All right, copy the agenda. Warm-up number 55, transformation of functions. We're still in the middle of transformations. I'm giving you guys plenty of practice, so make sure you're keeping up with your home play and you're not just copying from someone that's close to you that did their home play just to turn it in. My goodness. Tonight's home play, only one problem. Only one. Let's go. Oh, yeah. We got this. All right? So, last night, oh, here's the code for the home play, RT6FX. RT6FX. And once again, guys, as we're going through our presentations and our home play, I think we only had issues with the code one time in the past. However, if you encounter that, just remember that right after this one, in the YouTube video, you should see the home plate that was assigned the previous night and the home plate for the day. It should be on that video in case, you were wondering. Anyways, last night's home plate, that's a gift from me to you. Let's go. All right? So, with that said, get a Cornell note ready, please. I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. All right? So by now we know what the definition of a function is. In your own words, tell your neighbor, what is a function? What is a function? All right, looks like Mariah's got it. Very good, Mariah. I see you. All right, Mariah, what is a function? I heard input. The same input should have the same output if it repeats. I'll take that. Pretty good. Not bad. So we got that. We don't need a Freyer model. And then we're talking about parameters, and the parameters we said we are so far on H and K. Okay? So today we're moving on. We're going to add one more. Let's go. Bring it, Q. So, with that said, get in front of you a graph paper. At the top left, I want you to write example super duper Q, and it says graph f of x equals x squared using the domain -3, -2, -1, 0, 1, 2, 3. You're going to copy this table. Look up. Then you're going to copy a green table right next to it like that. Look up. And then you're going to copy a red table that looks like that right next to that. I'll give you guys some time to set that up, a couple minutes. Once again, at the beginning I said when you're done with your warm-up, you need 3 graph papers from the back. So make sure you get those. Give you guys some time. Set it up. All right, here we go. Y'all ready? Ready? Here we go. It's going to go pretty fast. So stay focused. We're going to start with the original f of x. Y'all ready? So, we're going to start with -3, and it says to the second power. So what is -3 times -3? 9. That is correct. Fill that in. Oh, sorry. Next one. -2 squared. -2 times -2 is 4. -1 times -1. 1. 0 squared. 1 squared. 2 squared. 3 squared. Let's plot those. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. Graph it, label it, f of x. Okay? So now we're moving on to the new portion. This is where I need you guys to stay focused and pay attention. Okay? You already have the table. You already have the graph. Writing utensils down. Look up to the screen. Here it goes. So, let me mute the music in the back. So I'm going to go ahead and fill out the green table. But I'm not going to say any words since you already know the process is. And hopefully you see what I see. So I'm going to just do a quick think aloud. The only think aloud I see is that I have f of x here in green. And there's a number outside of f of x, and that number now is in the front of f of x. Okay, so if it's in the front, that means it's multiplying. Okay, so all right, talk it over to your neighbor, let them know what the process is to fill in the 3f of x, 3f of x. All right, so what would be our next number here? Let's see, looks like Caesar's got it. I see you, Caesar. But let's go with Annette. Annette, what goes right here? So we got 27, we got 12. 3. Hands if you agree with 3. That is correct. How did you find 3? Well, we look at the x being what? -1, but we need what? We need f of x when x is -1. What was that? 1 times 3 is 3. Therefore, the rest of them are what? 0, 3, 12, 27. Hands if you got that. All right, let's graph that. Here we go. -3, 27. It's not going to fit on mine, so I'm just going to say that it's somewhere over here. Somewhere over here. -2, 12. -1, 3. 0, 0. 1, 3. 2, 12. And 3, 27, way over there somewhere. So since I'm not going to be able to graph 27, I'm just going to put the arrow at the end right there. All right? Are we there so far? Okay. So you're like, that looks weird, Mr. Q. I know it does. So here's where I need you to put your thinking cap on. Ready? Okay, writing utensils down, look up to the screen. I started with this original f of x. Oh, let me label this one g of x. I started with the original f of x. There it is. And now we have a new parameter that appeared here in front of the f of x that's multiplying. So, think about it. If this is the original, and this is transformed because of that parameter, what would be one word that you would tell your little person in your life that walks in every time that you're doing your math stuff? What do you do to the black one to make it become the green one without showing them any numbers? Talk it to your neighbor. Well, what happens to the black one to make it the green one without using any numbers? One word. All right. Looks like Mario's got it and Enrique's got it, but let's go with Joseph. What happened to the black one to get the green one? One word. Those are a lot of words. Yeah, it became longer, but one word. Actually, no, compress means that it makes it smaller. Rachel, stretch. I want you to write the word stretch. Stretch. All right. So, it did stretch. However, let me point out like something really quick that you need to really see here. Look up. Look up, please. So watch. I'm going to highlight the first, from 0, 0, from the original f of x, the first 2 points are here. Do you guys see them? You guys see the 2 points? What is the y value there? What is it? 1. Okay. Now let me go to the green one, to the green graph. The first 2 points other than 0, 0, look at them. What is the y value there? Think about it. What is the invisible number here in front of f of x of the original? 1. And here in front of the transformation? Let me show you something else. Here go the second points. Look up. Oh, no, those are the third points. My bad. The second points. What is the y value? 4. Does everybody see it? All right. For the second ones. Now let me go to the green one, to the second points, which are here. What is the y value? So over here for the original, it was 4. Now over here, it's what? Tell your neighbor what's happening to the y values with the new transformation. Yes? All right. Oh, Enrique's here. All right. Welcome back, Enrique. All right. So keep that that observation in your noodle. Let me move on to the next one. Let me throw this highlighter away. This one. This one. And this one. All right. Let's go to the red one. Let's fill this in. Here we go. Look up. So, writing utensils down. Look up to the screen. So, now instead of 3, it has 1/3. All right, here it goes. Fill in the last 2. Tell your neighbor how we got those values, please. All right, let's see. Looks like Joseph's got it. But I'm going to go with Kelly. What are my 2 last values right here? 4/3 and 3. Hands if you got that. That is correct. Now, how do we get these numbers? Well, let me start with the green one just to recap. I looked at -3 over here. The original f of x was 9. And this one said to multiply the f of x times 3. That gave me 27. But this was 3 times f of x. Is this one 3 times? No, this is 1/3 times f of x. So what was f of x over here? 9 times 1/3 is 9/3, which is 3. That is correct. 4 times 1/3 is 4/3. 1 times 1/3 is 1/3, and so on and so forth. Let's graph that. Here we go. Negative 3, 3. Negative 3, 3. Negative 2. 4/3 is 1 1/3, so 1 1/3 is about right there. Negative 1 1/3 is close to the x-axis. 0, 0. 1 1/3. 2 and 1 1/3. And 3, 3. All right. So, oh, and we label this one g of x. All right. So, with that said, we said that from the original black one to get the green one, Rachel said, well, Mr. Q, we stretch it. Okay. And yeah, each of these points continues stretching that direction. But what determined that? Well, that it was a whole number multiplying f of x. So now that we have a fraction multiplying f of x, this is what we get. Talk it over your neighbor. What is the one word that you would say happened to the black one to get the red one now that we're multiplying times a fraction? Talk it over here. What would be one word? One word. Like Enrique's got it. Very good, Enrique. Good. But let's go with Kelly. Pass someone, Kelly. Who? Oh. Go ahead, Yulisa. One word. This one was stretch, and this one is shrink. Or, in other words, compress, as Jesus was trying to enlighten us earlier. I'm hearing Jesus. Yes. So, conclusion. When multiplying f of x by a whole number, right? That's what we did here. Does everybody see that? 3 is a whole number. The new graph blank. The new graph what? Mario. Stretches. That is correct. And, this is a semicolon then. And when multiplying f of x by a fraction or decimal, the new graph blank compresses. Yes, compresses. Does everybody see that? Yes? All right. Woo. Well, guess what? That's our new parameter. And notice it goes in front of f of x. So how does that look like in my general rule, Mr. Q? All right? Write this down in your notes. Here's our general rule, our new one. Right. General rule. G of x equals a times f of x minus h plus k. Write that down. All right, did everybody write their rule? Yes? So, Here we go. In blue, what does K do? Tell your neighbor. What does K do, Geo? Up and down. So draw arrows up and down. Up, put a little plus sign, so when we substitute a positive number here, the function's going up. If we substitute a number that's negative, the function's going down. And where's that number located? Outside of the parentheses to the right. You guys see the parentheses here? That number's going to be outside and to the right of f of x. Okay. Next, what does h do? Geo. Yeah, side to side. Left and right. Going to the right, if we substitute a positive number, it goes to the right. If we substitute a negative number, it goes to the left. Okay. Next, what does A do? It does two things. It what? Stretches or compresses. And this is what we call, like this is what we call vertical. Vertical. Stretch and compress. When does it stretch? When it's a whole number. When does it compress? When it's a decimal or fraction. All right. Enough of the theory. Let's put it to practice, yeah? Let's go, Yulisa. All right, get a graph paper in front of you. Here we go. Write this down. Example 1Q. Graph f of x equals x squared, then transform given g of x equals 3 times x minus 5, close parentheses, squared, plus 2. Write that down, please, on the top left of the new graph. I'll give you some time. Hurry up. Write it down first, so like that we're on the same page before I... All right, Dana, what do we do? Yes, and how do we graph that? What do I do? Monte, help her out. Table, yes, that is correct. F of x, -2, -1, 0, 1, 2. Remember, if they don't give us any instructions just to graph, make a table. All right, Mario, go. 2 squared. 1 squared. Your brain was glitching there for a little bit. Let's go -2, 4, -1, 1, 0, 0, bless you, 1, 1, 2, 4. This is our f of x. All right. So, before we do anything, check this out. We're going to have to do this in the 2 steps. The first step is this one. Look up. The first step I'm going to do in green, so circle this. And tell your neighbor what that's going to do to the entire function before we move it. Tell your neighbor what that's going to do to the entire function before we move it. Everyone, what's that going to do? Stretch it by what? By 3. So, here it goes. This is how we do the first step. Look up. We need to stretch the points before we actually do the movement of the points and graph our final graph. Here it goes. So, each of these points are going to stretch by 3. So, let's start with this one. Instead of being at -2, 4, what is 4 times 3? 12. So, this one's going to be up here at the 12, including this one. Notice what I did with these two? The y value was what? We multiply times 3, so we move these 2 points up here. Let's focus on these 2 now. What is the y value for these 2? 1 times 3 is? So this one we move up here to 3, this one we move up here to 3, and this one stays at 0, 0. We got it? All right, so that was step 1. Step 2, we need to move it according to H and K. Tell your neighbor where we're going to move those 5 green points. Where are we going to move those 5 green points? Where do we move them? All right, Monse, pass someone. Marim, where are we moving it? Five to the right. So we're going from left to right. We started with 3. Now we're going with this number. We're going 5 to the right and 2 up. So with blue, each of these points, 5 to the right and 2 up. Here we go. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. 1, 2. This green one right here. 1, 2, 3, 4, 5. 1, 2. This one. 1, 2, 3, 4, 5. 1, 2. And this one. 1, 2, 3, 4, 5. 1, 2. And this is our final transformation, and you label this one G of X. Ooh-wee. Yeah, Hugh, give us a lot of these. Let's go. Send me a picture of what you did, please. I want to see your work. All right, as you're sending that in, here goes the process one more time. It said here, graph the function f of x equals x squared, then transform. So the first thing we did is make a table, graph our f of x, there it is, and we have our 5 reference points right here. Next, we start off with our transformation, and what is the first thing we do? Either we stretch it or compress it. In this case, it was 3, so it's stretched by 3, each of those points, yes? All the 5 points stretch, and 3 times 0, 0, that's why it stays 0, 0. However, we didn't graph our function there because that's not the final one. What was the final one? Moving it 5 to the right and 2 up. Once we have our final set, all our points, we label it G of X, and that's our final transformation. From 1 to 5, I'll come to bar you up to right there. 4, 5, 4, 5. Okay, let's do another one. Turn your paper over, next graph paper, copy this. Example 1 super Q. And it reads, graph f of x equals x squared, then transform given g of x equals 2 times x plus 3, close parentheses, squared, minus 7. All right, I'm going to give you a head start for this one. See if you can do this one completely by yourself. It's very similar to the one we just did, okay? All right, I'm going to send that to your screen. There it is. Go. All right, for the sake of time, here we go. What is the first thing we do when it says graph? Well, we make a table, Mr. Q. Here it is. And we graph f of x equals x squared, and here it is. We label that f of x. All right? So far, so good? Yes, Mr. Q. All right, Gio's going to guide us through the next part. Again, we're going from left to right. What do we notice? It has a multiplier of 2. So Gio, what does that do to these 5 points? Stretch. So make sure you label that stretch so you remember to stretch the points. So here we go, Mario. If these 2 points are at 4 and we're stretching by 2, where are they going to be at now? Ooh-wee. At 8. That is correct. These 2 moved up to 8 because they were at 4 of y, and now they are at 8. How about these 2 right here, Enrique? Where do these 2 move to? If they are at 1, they move to 2. That is correct. Here and here. The other one is 0. All right. However, we need to move the whole thing, and at the end, graph it in red. according to these instructions. So tell your neighbor what instructions did you use, please. Then we're going to pass it to Annette, and then she's going to guide us through the last portion. Tell your neighbor where are we moving this to? All right, Annette, where to? 3 to the left and 7 down. Hands if you agree with that. That is correct. So I'm going to go 3 to the left. 1, 2, 3, 7 down. 1, 2, 3, 4, 5, 6, 7. This one, 3 to the left. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. This one, 7 and 0, 0. And we label this G of X. Send that in, please. All right, from 1 to 5, how comfortable are you with this one? Yeah, now we got some more 5s and 4s. All right. Send that in, and here goes the last one. Graph f of x equals x squared, and then transform g of x 1/2 x minus 8 squared minus 10. So, go ahead and get that one done. Hurry up. Copy and go. All right, for the sake of time, what is the first thing we do? Enrique. Oh, my goodness. Table. Oh, okay. -2, -1, 0, 1, 2. And what are my f of x values, Mario? What? Oh, my bad. What? Uh-huh. What else? Come on, Mario. It's like Mario just started throwing numbers out there. 4, 1, 50,000. My goodness. All right. So now I'm going to change to red in this case. Here's a half. Tell your neighbor what that's going to do to all the points before we move them. It's going to do what? Starts with the letter C. Compress, my goodness. Compress by half. So if we were at 4 on here for these two, they go to half, which is 2. If these are at 1, they go to half. So they go here, and then 0, 0. And then we move them. Yeah? From 1 to 5, how comfortable are you with this? Yeah, we got this, right? Make sure you do your home play. Those of you following on YouTube, make sure you put in some time to practice. See you guys next time. Peace.